All right, the scenario for task number 2 is that Claire and Han have summer jobs stuffing envelopes for 2 different companies. Claire's earnings can be seen in the table to the right, and Han's earnings are represented in that verbal description. So let's focus on the table first because I think that's the simpler representation to look at. If you label the first column X and the second column Y, you should see that we're going to set up a ratio of Y over X, or we're going to set up the dollar amounts over the envelope amounts. And if you set up 40 over 400 or 90 over 900, you get that it equals 0.1. And so if you were asked to interpret what does this mean, you might start with this stem of it's 0.1 what per what, and we want to do the Y over X label. And so we have 0.1 goes with dollars. And so rather than write out dollars, I'm going to actually just put the dollar symbol in front of the 0.1. And then it actually makes sense to put 0.0 or a 0 after the 0.1 to represent money. So that's 10 cents per every 1 envelope is what the X represents. And so Claire earns 10 cents for every envelope she stuffs. And then if you compare that to Han's verbal description, we're going to set up the same ratio of dollars to envelopes. And so if you look, he earns $15 for every 300 envelopes that are stuffed. And if you simplify 15 over 300, you get 0.05. And then putting those labels again with the rate, you get $0.5 per every 1 envelope stuffed. And so then you're asked to represent these scenarios not only as a verbal description and as a table, but also as an equation and as a graph. So I'm going to ask that we start with the table. And really what we can do is we can copy down the number of envelopes and the money. So if you look at my table, I have number of envelopes and money for Claire. And then I've also started with the 400 and the 40 and the 900 and the 90 that were in the original table. What's additional are the last 2 rows, and you should recognize the 1500. If you take a look at part A above, it asks who would make more money after stuffing 1500 envelopes. And so I want to calculate how much money do each of them make after stuffing 1500 envelopes. And so if you use that constant of proportionality, the 0.1, I also just threw 1200 envelopes in there to get 4 different values in each column. And then we get $120 for the 1200 envelopes and the $150 for the 1500 envelopes. And then what I did was I took all of the X values for Claire, and then I made another table for Han to consider how much he would make for each of those number of envelopes, so that when we graph them, we get, even comparisons. And right away, you can see probably from the rate that Claire is earning more, 10 cents versus 5 cents. And then you get those total dollar amounts when you look at the 400 to the 400. Claire earns $40 versus Han, he only earns $20. And then I'm going to go ahead and jump to the graph next because we have now some values that we can graph on a table. And looking at the values, these are proportional relationships, so you should always start with your X at 0 and your Y at 0. And then considering what's the biggest X value in either table, we end both tables with the 1500, so that's going to be our biggest X value. In terms of the Y value, the biggest Y value in looking at both tables is the 150. And then if you look at the graph below on your papers, you see that you have 14 grid lines to spread that 1500 and the 150 across. If you try to go up by 100 or 10, you're only going to get to 1400 or 100. So I'd recommend going up by 150 or 15 and going up by 200 or 20. So now I'm going to ask that you probably just pause on the graph and make sure that the points that you're plotting from the tables that are shown here are matching the plots that I have on my table. Make sure that you also have your labels. So the number of envelopes is your X, and the number of dollars earned or the amount earned is your Y. I went up by 150 on my X's instead of 200, which would also work. And then I also went up by 15s to be consistent instead of 20s. But again, 220 would work for your scales. Pause it here so you can make sure you get accurate plots for Claire in the orange is how I have it labeled, and then Han is in the purple. And in no particular order, we haven't then formally addressed Claire and Han's verbal descriptions, and then we haven't formally addressed the equations. So I'm going to go ahead and jump up to the verbal descriptions. Han was given to begin. So Han earned $15 for every 300 envelopes stuffed. And then we were able to calculate that 5 cents per stuffed envelope. So that's something that we calculated from the given verbal description. Clare, we then also got from the table the 10 cents per every stuffed envelope, and that's the verbal description, is putting it into a sentence. That's it. And then you take this K value, this rate of change, and you go ahead and put it into the general form y equals kx for the equations below. And for Clare, it's going to be y equals instead of k 0.1x. And for Han, it's going to be y equals instead of k 0.05 for x. Or sorry, 0.05 for k, then times the x. And then as you're looking at all these representations, I really hope that you guys are identifying where are the k's in each of the representations. And then you can use each of these representations to go back and answer the questions in part A, B, and C. So for part B, I've already addressed that you can just see the verbal description that tells us the rates of change. For part A, who would make more money after stuffing 1,500 envelopes? We'll look at the table and see how much is made. We have 1,500 gets us $150 for Clare, and 1,500 gets us $75 for Han. So we can clearly identify that Clare makes more money. And then if you take the $150 and subtract the $75, you get that she makes specifically $75 more dollars. So Clare earns $75 more. And you've shown some of the work in the table to get the $75. You can take the 150 and subtract the 75 very specifically. And then in terms of who gets paid more in their job, make sure that you very directly answer this question, but we have already seen that Clare earns more money. And you can speak to the rate, the constant of proportionality if you'd like. But again, we can see this in all of the work, and then that completes the group task number 2 problem.